Hello and welcome to the unit on data structures. So this is the part 2 of this particular unit. If you haven't watched the earlier parts, then you can always check out. I have given out the links in the description. So today's topic of discussion will be introduction to stacks and string reversal. So I'll discuss about stack in details, and along with that I'll discuss about an application of stacks, which is the string reversal. So as per the CBSE curriculum, this is your CBSE curriculum for class 12. So out of this, I'll be discussing about stacks in today's session. So what is a stack? A stack is a linear data structure in which insertion and deletion happens at only one end, known as the top. So what is it? It is a linear data structure. I've already discussed what a linear data structure in part 1. You can just refer to that if you haven't watched it already. So in a stack, insertion and deletion happens only at one end, and that end is known as the top. The elements of a stack are accessed by a technique called LIFO. So how the elements of a stack are accessed? They are accessed by a technique. The name of that technique is called LIFO, or last in, first out. That means the last element to be inserted into the stack will be the first element which is removed from the stack. So insertion of a new element into the stack is known as push. So if we insert one element into the stack, that is known by the term called push. Deletion of a new element from the stack is called pop. So for deletion we have a term in stacks, that term is known as pop. So let's consider the stack. So initially the stack is empty. When stack is empty, top is equals to -1 or none. So when stack is empty, top will have the value of -1 or none. So if you get the value as -1 or none, you should understand that the stack is empty currently. So it means that stack is empty. Now let's say we have an item called 8 and I want to push 8 into the stack. Pushing means inserting an element into the stack. So what I'll do, I'll just push it into the stack. So when 8 will be pushed into the stack, now the value of top will not be -1, it will be incremented by this formula. What is the formula? Formula is top equals to top plus 1. What is the current value of top? The current value of top is -1. So -1 plus 1 will give you how much? 0. So currently the top will have a value of 0. After that, let's say we want to insert the second element, which is 12. So as you already know that insertion and deletion happens only at one end, known as the top. So now 12 will be pushed into the stack. So when 12 will be pushed into the stack, now the value of top will again be incremented by using the earlier formula, which is top equals to top plus 1. Now top is 0, 0 plus 1 is how much? It is 1. So current value of top is now 1. Now let's say I want to remove elements from the stack. For that we have a term, that term is known as pop. So if I want to pop, I cannot pop out 8 before popping out 12. Why? Because insertion and deletion happens only at one end, that end is known as the top of the stack. So now 12 will be popped out. So what will happen? Top will be decremented by the formula top equals to top minus 1. So now top was 1, 1 minus 1 is how much? 0. So now top is 0. So when we pop out the second element, now then pop will again become how much? It will again become -1. -1 signifies that the stack is empty. Now we need to know certain terms associated with stacks. So the first term is peak. What is peak? It refers to inspecting the value at the stack's top without removing it. It is also known as inspection. So let's consider one stack. Let's consider, let's say we have a stack. Let's say this is the stack. We have the elements 2, 4 and 9. So if I just want to see what is at the top of the stack, what is at the top of the stack? 9, without removing it. That is known by the term of peak. So it refers to peak. Next, let us go to the next term, which is stack overflow. What is stack overflow? When a stack is full, no new elements can be added to the stack. This condition is known as stack overflow. For example, see here, let's say the capacity of this stack is 3. So if I want to again push one more element, let's say 18 into the stack, can it be pushed? No, it cannot be pushed. Why? Because the stack is already full. So when the stack is already full and you are still trying to insert a new element into the stack, this condition is known by a term known as stack overflow. Okay, and overflow leads to an error. But in Python there is a special thing that if we implement stack with the help of list can grow and shrink in size automatically. So the condition of stack overflow does not come in case of Python. Next term that we want to discuss it. Okay, so here this is the thing that is written, that for stacks implemented through linear list, this problem will not arise because lists can grow and shrink in size until all the memory is exhausted. When all the memory is exhausted, obviously there will be no space remaining, and then the stack overflow condition will arise. But in normal situation, stack overflow condition will not arise if we are implementing it through Python and linear lists. The next term that we want to discuss is stack underflow. So what is stack underflow? When a stack is empty, there are no elements to be deleted from the stack. When one tries to delete or pop an item from an empty stack, the condition is known as stack underflow. Let's say now what is the status? The status is that we have three elements, those are 9, 4 and 2. So at first let's say we'll pop out 9, then we will pop out 4 and then we'll pop out 2. So when after 2 is popped, what will be the status of the stack? This will be the status of the stack with top equals to -1 or none. So after that, if we want to pop out another element from the stack, it will lead to an error known as stack underflow. Underflow means there are no elements in the stack and still we are trying to pop out some element from the stack. So these are the terms, basic terms related to the stack which we have to know. Now stacks has various applications in programming. So what are the applications? The first application is string reversal. In today's session we'll be concerned basically on string reversal only. The second application is conversion of infix expression to postfix expression. So we'll discuss more about infix and postfix in the next session. And then we have evaluation of postfix expression. So let's start our discussion with string reversal. So all of you know what is string reversal. String reversal means, let's say we have a string called cat. If I want to reverse it, it will be how much? TAC. It can be done using some other methods also. Now we will be concerned basically how to do this string reversal with the help of stacks. So a string can be reversed using stacks by the following steps. We need to follow a certain number of steps for doing the process of reversing strings. So what is the first step? The first step is that to push each character of the string. So we have to push the characters one after another, and then the second step says that we have to pop out each character one after another once the entire string is pushed. Let's try to understand it with the help of a diagram. Let's say we have an empty stack now. Empty stack means what will be the value of top? Top will be -1. So let's say we want to push C now. So C will be pushed, and then let's say the string is cat, then A will be pushed, and after that T will be pushed. So this is your step 1. So after that we need to pop out each character one after another. So this is the current status. So at first which will be popped out? T will be popped out. After that A will be popped out and C will be popped out. And after that it will be displayed via the output screen. So this is your step 2. So now we'll see a program in Python as to how to reverse strings. So this is your program. Let's try to understand this program in details. So this is a program in Python to reverse a string using the concept of stacks. So here we have DEF. So this part will be skipped from line number 2, line number 5 will come, then line number 7, then line number 9, and the program will start executing from line number 18. So here what will be printed? String reversal using stacks. This is just the name of the program. After that, as equals to, I have taken a variable as equals to input, enter the string to reverse. Let's say we have entered the string as CAT cat. So in memory it will look something like this, CAT. It will have an index. I am giving only the forward index, which are 0, 1 and 2. So after that the function calling will, so the name of this string is s. After that function calling will happen in the 20th line, which is s equals to reverse s. That means the string cat will be carried from the 20th line to the 9th line. So it will be carried from this line to this particular line. Here what will happen, n equals to ln s. Ln, what ln does? Ln finds out the length of an object. So what is the length of the string? The length of the string is 3. So what will be the value of n? The value of n will be 3. After that again another function calling is happening, which is the function create stack. So the control will now go from the 11th line to the 2nd line. So under that what we have created an empty list. Okay, so which is the name of that list is stack. So stack is an empty list, and then that empty list has been returned and it will be received by line number 11. So in line number 11 what we have this as the status. That means we have an empty list now. After that what we have in the 12th line, for I in range 0, n. That means for I in range 0, n, what is the value of n? N means the length of the list, which is 3. So what will be the possible set of values accepted by I? Those will be 0, 1 and 2. What will be accepted at first? At first 0 will be accepted. After that another function calling is happening here, which is push. What this function will carry? It will carry the stack, which is an empty list, and as I, as you can see here. What is the value of I now? The value of I now is 1. So as 1 will be carried. Sorry, now the value of I is 0. So as 0 will be carried. Now what is stored in S0? C is stored in S0. So what will be carried here? The empty string, the empty list, and C will be carried. It will be carried to which function? It will be carried to function push, which is in line number 5. So after that what is been done? Stack.append item. I think all of you know about the append function from your class 11 concept. What append does? It will add a new element to the existing list. Okay, now what is the status of the list? This is the status of the list. That means now the list is empty. But now we have appended an item. What is the item? The item is your C. So C will be the first element of the stack. Okay, so after that the control will again come to the to line number 12. Now I will take the value of 1. So what will be sent now? The stack, which is C, Si. What is the value of I now? The value of I now is 1. What is stored at 1? A is stored at 1. So A and C will be carried to the function which is at line number 5. Okay, so here what we have? Stack.append item. So now what is the status of the stack? This is the status of the stack. With that a new item has been appended. Which is the item now? A is the item. So now what will happen? Along with C we will have a new item there, which is A. Okay, so this is the current situation of the stack. After that the control will again return to the 12th line. Now the value of I will be how much? Now the value of I will be 2. So now what is the status? C and A. So this stack will be carried, and along with that as I will be carried. The value of I now is 2. What is the value presented? 2. T is the value presented 2. So what will happen? The control will now go from the 13th line to the 5th line again, and here again appending is happening. So the current was C, A. So now after appending, here we have to join another element, which is your T. So this is the current status of the stack. After that the control will again come to the 12th line, but here we see that the list has been exhausted now. So now 12th and 13th line will be skipped, and after skipping 12th and 13th line, what will happen, it will come to the next line. What does the next line says? Okay, let me just clean it a little bit. So after that it will come to line number 14. So this is now stored in the string. So string was now CAT. Okay, so this was the string now, and this is the value of stack now. So now the string has been assigned an empty string. So this CAT will be replaced by the empty string, and now we have the value of s as an empty string. So in the stack we have CANT, but in the string s we have an empty string now. So from line number 14 now, which line number will come? Line number 15 will come. So what is the status there? For I in range 0, n. So again we'll just do the same set of operations. Let me erase this. So here we have for I in range 0, n, that means 0, 3. What are the possible values of the set? 0, 1 and 2. At first I will take the value of 0. So in the 16th line what will happen? S equals to s plus pop stack, that means s equals to s. What is s now? S is an empty string now, plus pop stack. So what the pop function will carry? It will carry the stack which is CANT. So it will go to the function with line number 7. Here what we have? Return stack dot pop. So this function also we have already got in class 11. The use of pop function is to remove the last element from the list. So what is the last element from the list? So this is our list, or this is our stack. What is the last element? The last element is T. So T will be removed. So when T will be removed, what will be the status now? The status will be this one, C and A. So after that the removed element is returned to line number 16. So we have s equals to an empty string. Empty string why? Because of line number 14 plus the popped out element. Which is the popped out element? The last element, which is T. So we have T. I think you already know about the concept of concatenation of strings. So we can, concatenation means joining two strings. So if we join an empty string with T, what will be the result? The final result currently is your T only. Okay. So now this iteration is not yet complete. Now I will take the value of 1. So when I will take the value of 1, it will come again here in the 16th line where we have s equals to s plus pop stack. What is s? S is T. T plus pop stack. That means the entire stack, that is C and A, will be carried now to the line number 7 and then to line number 8. In line number 8, what is happening here? The popping out is happening. So which item will be popped out now? The last item, which is currently A. So when A will be popped out, what will be the status of the stack? This will be the status of the stack, and the popped out item is carried to line number 16. So in line number 16, what we'll have? Currently s equals to s plus pop stack, that means s equals to T plus, what is the popped item? The popped item is A. So T plus A, what we have now? We'll have TA in place of S. Now still the iteration is not complete, so it will now take the value of IS. How much? It will now take the value of IS 2. So then it will again come to the 16th line. In the 16th line, what we'll have? We'll again have the same formula, which is S equals to S plus pop stack. What is the current value of S? The current value of S is TA plus pop stack. What is there in the stack now? C. So it will go to the line number 7 and then it will go to line number 8 where that item will be popped. What will be popped? T will be popped, and that popped item is returned to the 16th line. So here finally we'll have S equals to TA plus C. What will be the final result of S equals to TA plus C? So the final result will be one string, which is TAC. Now you can see that the iteration of line number 15 is complete because the entire set of range has been exhausted now. So after that, this particular loop will be broken and it will come to line number 17. In line number 17, what we have? Return S. what is stored in as TAC. So this TAC will be returned to line number 20. So what will be stored in line number 20 now? TAC will be stored in line number 20. So finally we'll get the output as reverse string is TAC. So I'd like to show you the output. So this will be your output. So string reversal using stack, enter the string to reverse. If you give the input as TAC, you will get the reverse string. If you give the input as CAT, you will get the reverse string as TAC. You can use any string for that matter in input. So now let's run and see this program if it runs perfectly or not. So this was the program which I have discussed and explained it to you. So if I run this program now, so you will get this. So let's say I'll give the input as CAT and press the enter key. So what is the output I am getting? I am getting the output as TAC. Now let's move back to the slides. So this is our slide now. So this was the program related to reversing of strings. So here this function of line number 5th, it is known as the push function. It is helping in inserting the characters of the string one after another using the append function, and second is the pop function. It is helping in extracting the elements, which is your step 2. Step 2 has been performed by your line number 7, which is the pop function. It is helping in removing the elements one after another. After that, when I see the output, this is the output with the input as CAT. Okay, so I hope that this session was useful. I'll see you again in the